somebody who voted before has a problem with this, then I haven't made a final decision, but you have to let me know that. You can do it by a private chat or come to my office hour and we can talk about what options are. But so far, as this is the United States, apparently, we have 8 people with no vote. And we have 13 people saying after and only 3 saying before. So those 8 people who had no vote are still not enough to swing it for not being before. But if there is a real personal reason you can't do it, then I will certainly take that into consideration, because we can finish the material on Thursday. Okay, so lab today. So if you recall, what we're doing today in lab is a Physio X. And I didn't prepare because I was busy chatting about dogs, I guess. But let me go into my mastering, and I hopefully will easily get in there. Sometimes I have more issues than other times, but hopefully not this time. There we go. Okay. And again, it doesn't matter which of the 2 courses that you use. If, some of you I see are enrolled in one and some in the other. That does not matter. Let me get mastering to open here. Hopefully. I'm still waiting on it. But I think I gave you how to get there. You're going to go into something called Physio X, and I think you go into that. If I could get my mastering to open. Let me try again. Sometimes it does give me issues. I don't know about you. Oh, that's looking better. I was hoping it looking better, but great. Okay, let me go in through, I think I went in through Safari. I think that's the problem. I have to go in through something other than Safari. New window. Just go mastering IT. I think it doesn't like Safari. Okay, here we go. Yes, it's coming now, finally. It does not like Safari. All right, so I am now going to share the screen. Okay. So if I remember rightly, I sent you this, but you go into my study area. And under this, you should find Physio X. So the next step is Physio X. And then you're going to open up exercises. And we're going to be, do I have it written down? Which ones we're going to do? I know I do in the other. You're going to have to scroll down till you get to the kidney renal system. And we're going to be doing several activities under renal system. So what you'll see, I'll try the first one you're definitely doing. When you open this, what you'll find is it's step by step. Honestly, this goes slower than it ought to go, whoever designed this, because it's clear, that you ought to hit, a button, and then you ought to record the data, but they give you a new slide for each one. So the other part of this is that there's a background here. I'm hoping you're seeing all this. And then all this equipment we're not worrying about. There are a bunch of questions embedded in it. I don't expect you to turn those in at all. Sometimes they give you the answer. There's also at the end, like a quiz at the end that you can use. I think they're all useful. I don't expect any of that to be turned in. What you're turning in is the handout where you're recording the data. So I'm not going to actually run it. So you have to continue if you're not going to do that. You're going to run this little mock machine, which allows you to filter the blood. And it tells you how to adjust these with the pluses and the minuses and what numbers you should be having on this. And then in the end, you'll get a urine volume, and you'll be getting your capillary pressure and your glomerular filtration rate. So when you say record data, you can see the button here. It's going to all show up in this table. So you can see the table is only showing you 2 boxes, but later when you add more data, you can scroll on this. And so this is where you're getting the data that you're going to enter into the handout. So the sort of thing I'm saying slows it down is that each time you finish the run after you've made the adjustments on the afferent radius, the efferent radius, and that consequently changes things like these pressures up here. You run it, you hit start, and the blood is filtered. This fills up with blood. This fills up with a certain amount of urine. It does make you hit the record data button. Then you have to go back, and each one of these is a new slide, and hit start. You can go faster, but that means that you'll know, oh, I got to hit record data. Then I'll hit start. Then you're going to end up skipping a couple slides that tell you to do that thing. So I strongly recommend that you do this. Let me stop sharing in groups, because I found in person when we do this lab, people talking to each other, they fill out the handout together, and therefore, they work together. So is it okay with you guys? If it's not, then put in chat, no, I really want to do this all by myself. I'll just set you into breakout rooms. And if you want to be in with somebody, also put that in the chat, and then I'll turn you loose to run it, and you can ask me questions as if you have them as you go. But I think working with another person is really important on really getting the most out of this, because you have discussions about it. And remember, today, at the end of the day, your analysis is due. So how about if the lab is over at 12:45, how about at 12:30, so a little more than an hour? We'll get together and we'll talk about the urinalysis, but or a little after 12:30 if you haven't quite finished. You can always come back and redo this. You can play with some of the other exercises if you wish. I just picked out what I thought could be done in the hour you have. All right, so I don't see any messages in chat, so I guess I get to put the lab exercise 41. If you'd like and ask questions about that part of the table, that's fine. We just don't have time to go through the whole table. But the top part where it asks about normal values, I want to make sure we're all on the same page with those. And then at the very end where I ask you to integrate, take one disease and give me all the various things that might change in a urinalysis in that disease state, coming up with the answers for that. So let me get chat up in case I miss anything. Okay, so I hope you caught it this morning. But if you didn't, then the normal blood bicarbonate range is 22. Maybe I'll just type it in here. So bicarb is 22 to 26 milliequivalents per liter. So that number is going to come back to haunt you, because we are going to be on Thursday looking at how you regulate your pH. And one of the things you'll discover is that if a patient comes in and they have an abnormality in their pH, the first thing that's looked at is, after the pH is taken, is their PCO2 levels. What are their levels of carbon dioxide in their arterial blood? And the next variable is that one on this handout. And then that's going to suggest whether their problem with their pH has arose from a respiratory issue or a metabolic issue. To confirm that, what's examined is their blood bicarbonate levels. So this is the very real world here. So what about the blood PCO2? Well, I know you learned that it comes in at 45 and it leaves at 40, but in the range that the textbook gives you for what is normal, it can vary from 35 to 45 normally. Now, that doesn't mean that, you personally don't have a set point, but that's the range that it can fall in and be considered normal. So those two, I think, were a little challenging. Let me put that one up there. PCO2 range for normal varies from 35 to 45 millimeters Hg. What is millimeters? Whoops, sorry. mmHg. Okay. All right, so what about pH? Did anybody come up with that? You can either type it in chat or just shout it out, because that was definitely in the book, in the lab manual. What's the range? Okay. All right, let me make sure that I've got the same handout, because it looks like people are getting, I wrote fall 2020, that's what it is, on the top of this one. So let me make sure what's loaded was not the old one or something. Obviously, I do things over the summer and then, craziness happens, it looks like. So I want to go into Canvas. Okay, and go to Files. Hopefully it is not a different handout than you guys have. Analysis. It looks like it's put up this fall, so analysis handout. Okay, yeah, am I looking at a different format? I have an earlier edition. I must have the earlier edition in my binder here. Okay, so let me share this and we'll make sure, but I think these are good things for you to know. We can talk about them too. I guess I made it easier than it was last semester. Even though I have fall on it, I must have redone it. Okay, so hopefully you're seeing this, because this is more asking about what he got. You're right. What I just put up, though, I think are good things to know. I must have filed in my binder the wrong one. Okay, so was the color of his urine normal? And hopefully, yes. It was a light yellow, I assume, is what you have here. And what substance? Does anyone want to throw that into chat? Make sure I got chat here.
Urochrome.
Urochrome, right. And it's derived from what substance makes urochrome? You can just shout it out too.
Oh, bilirubin.
Bilirubin, right. So all that recycling, thanks. I got lots of answers. Bilirubin. That substance that you're breaking down red or red blood cells into heme, and then the heme is broken down into bilirubin, and that can be turned into bile. But the other option is, as it goes from the blood to the liver, where that could happen, is it's filtered out by the kidney. So what can cause a color to darken or lighten? So how about, let's start with darken. Can I write on this? I can't, but I can put it in here to everyone. What can happen to cause it to darken?
Dehydration.
Dehydration. How about some unusual colors? What if it's red? What could that be? Something you eat.
Beets.
Yeah, beets could make it look red. What's another thing that could make it? Well, blood could make it look red, which wouldn't be good, but so but blood. Wasn't there another color in there too? Anyone noticed? I'm trying to do this from memory here. Certain foods, beets. I guess that's all they had. How about if it's lighter? If it's really light, you can barely tell it's yellow. Looks like water. There's a good
Lots
suggestion.
of water.
Yeah, you're well hydrated. Hydrated, dilute urine. And then it does mention some drugs could change its color. And the only one I mentioned, I guess this is sort of a darker one, is vitamins, which can look, yellow, a brighter or a sort of fluorescence to it. So those would be good for that. How about things that could change the, do I have turbidity? Yeah, turbidity on it. So turbidity means it looks kind of cloudy.
A UTI infection?
Yeah.
Or, yeah.
Okay, because what you're probably seeing in there are a bunch of cells. Some of them are bacteria cells that you're flushing out, and some of them may be white blood cells that are battling the infection. Okay, another color that could change turbidity. So if you have a lot of protein or any other condition that would cause you to have lots of white blood cells released, like besides a urinary tract bladder infection, you might have glomerulonephritis. And then you're going to have a lot of cells and casts in your urine. And then they also mention under casts that it could have these mucoid casts if your filtration rate is really low. Okay, how about one normal and one abnormal condition that could alter the odor, specific gravity, or pH? So let's take them one at a time. Let's take odor. What could make the odor of your urine change?
Medications.
Yeah, we don't know how it would change then, but that could certainly do it. Medications. How about a food?
Asparagus.
Asparagus. And there are some folks that don't metabolize asparagus the same way. So sometimes it even makes it look kind of greenish, the color of the urine. What about a fairly common disease state? So put asparagus. What I'm thinking of is diabetes. How does it make your
Sweet.
sweet tasting? But did I spell it wrong?
It'll also really darken the urine.
It would potentially change the color, although actually I would say it would lighten it, if anything, because you would urinate a lot. You would be releasing dilute urine all the time. Why do you say darken? I'd have to think about it.
My ex-husband, when his blood sugar was going up, his urine got really dark, and he would drink tons and tons of water, and he would still have really dark urine.
Huh. Well, that's maybe something I don't know about. We'd have to ask Dr. Sundar why that happens. He probably would know. So where was I? Oh, I was thinking of the ketones. The odor would be that kind of smell of ketones, which is sort of a fruit-like smell, is what they call it, or acetone. Acetone sounds disgusting, but fruity-like smell sounds better. Okay, so we have one normal and one abnormal for the odor. What about specific gravity? What could change that? Remember, that's how much solute is in there. So what about dehydration again? Right, because, yeah, dilute when overhydrated. Okay, if would increase it. And as someone else says, it could be decreased if it's really dilute. And someone else put decreased flow to the blood flow to the kidney. So what I think you're thinking again is slow flow, and maybe you get some of those mucoid casts that maybe that's what you're thinking. Okay, and we're getting a whole slew of them here. So dehydration, diabetes again, because of course you're adding sugar, so that's a solute. Infections, and there's a variety of type of infections that this person lists, but some of those infections might add white blood cells, which are not really dissolved. They're not really a solute, but you might also have casts associated with that, with infection. Yeah, so those would all be good. In fact, I've been filling my old one, which in some ways I like better because it's kind of all cohesed on that one. I don't know why I switched over. Glomerular nephritis would increase protein levels. And if you have protein in there, that's a solute, so specific gravity would go up. See if I'm thinking of anything else. Okay, that's probably good. So let me write this down. Glomerular nephritis. Why protein is being increased is when the glomerulus is inflamed, it's going to break down the filtration membrane, so proteins can sneak through, and then you get a higher specific gravity. Okay, well, it asks you to find specific gravity. I hope you can do that after the last time we talked, but it is a relative amount of solute, whereas water is defined as 1.00. Anything above that, so 1.01 is the normal range, which you should know the normal range. I guess I ask you to write it down in here. I think I've changed this so that it would match more what Kevin is doing, but anyway. Okay, so then you're filling this out. Does anyone have any trouble with this table? Have you managed to find things you need to know in the table? Or any questions on it? I don't see anything in chat or anybody jumping up and down. So it says the test did not test for hemoglobin, but that is in the table. So I didn't put it here, not this table. It's the table in the lab book. So what is the condition called, and what would be an underlying cause? So in the book, it's called hemoglobinuria. So great, someone just put that in there. And then it does give causes. Anybody want to come up with a cause of hemoglobinuria? It's in the table and on 619 in the lab book. Okay, I got a whole slew of them. Hemolytic anemia, transfusion reactions. So there you're having red blood cells burst open. Hemoglobin is leaking through at a high rate. Hemoglobin's pretty big though, so that it must be that you have to break down the glomerular filtration membrane. And so they also include things like renal disease and poisonous snake bites to get it through it. Okay. So let me go to I have to click on this in order to let it move it. There we go, it's just slow. Okay, so then the cast. Now they sort of separated this for some reason in the lab manual. So in one area, they talk about hyaline casts, and in that area is right above the table. So these are these mucoproteins that build up when filtration rate is slow, because I assume it's mucus being released. And then that kind of clumps up cells together. So what would be a cause for this would be, it gives in here, these hyaline casts are made from this mucoprotein. When the filtration rate is slow, pH is low, or a salt concentration is high. And that causes some of the protein to denature, sticking all this, making a mess of sticking all this together in the urine. So are red blood cell casts and white blood cell casts, these kind of share something. Anyone want to put in why you might get a red blood cell or white blood cell cast? Now, the information for this is also mentioned in that paragraph, but if you go to the last page where they talk about organized sediments, they also cover it. Yeah, kidney stones, which could cause bleeding. And then when you have red blood cells kind of hanging out in the bladder, they could end up clumping together. And I don't think they show very good pictures of them in here, but you can see them like stacked together in a group. How about white blood cells? Well, any kind of infection, you're going to cause white blood cells, whether it's glomerulonephritis or the pyelonephritis, which is a bladder infection. You're going to potentially have white blood cells invade that area, and then they can end up clumping together once they're in the urine and coming out as these organized casts. So these are considered, all three are organized casts. Unorganized casts, which would be excessive crystals, they give a bunch of reasons, but some drugs like sulfa drugs, it says, give them, and also sometimes infections can cause you to have elevated levels. Now this one, I don't expect you to break them down at all. They have a little picture that does break them down into some different types, if I remember right in the book here. You know, like these drawings of uric acid crystals or calcium oxalate crystals. I don't expect that. Just whatever it's saying in the paragraph above about unorganized casts and what they are. So hopefully now you can, oops, we're already at 1 o'clock. I'm sorry, I droned on this one and got lost in it. So I'm going to leave you now in case anybody shows up, but you're more than welcome to come to the next one, and I can reconstitute your group if you'd like to finish what you didn't finish on the Physio X. Okay, so let me stop sharing. And are we ready to go? Any questions? All right, so it's looking like the exam is the Tuesday after Thanksgiving weekend, and that means Thursday we will be finishing up pH regulation. We have some time for review on that day. And in the lab, we're going to be starting the digestive system, I believe. Okay, if I remember what I said in that case. All right, I'll see you Thursday, otherwise. When is